Hi everyone. In this video, we are going to discuss about the one of the important topic in Unit 4 in linear integrated circuit. The topic is the flash type ADC. ADC means analog to digital converter. This flash type ADC is one of the type in direct type analog to digital converter. Okay, it is also called as parallel comparator analog to digital converter. The definition of this flash type ADC is a flash type ADC produces an equivalent digital output. It produces an equivalent digital output for a corresponding analog input. Okay, it produces a digital output corresponding to the corresponding to the giving analog input in no time. No time means immediately. Immediately it produces the digital output corresponding to the analog input. Hence, flash type ADC is the fastest ADC. It produces the output immediately, then only it is said to be the fastest analog to digital converter. This is the construction of analog to digital converter, where it has 8 comparators. This flash type ADC contains 8 comparators which has both positive and negative terminals in each comparators. Okay, hence it is a two terminal comparator. This comparator compares this input voltage with this reference voltage and produces the digital output. These three outputs are digital outputs, where these positive terminals are uh, connected in one line. Then the input voltage, analog input, is given through this positive terminal. Then the negative terminal is connected with these resistors. Here 8 comparators, so we are using 8 resistors with it, where these negative terminals are connected between these resistors, where the reference voltage is applied through these resistors. These resistors are finally grounded. Analog input is given to the positive terminal of this comparator. Then we are using 8 to 3 bit priority encoder. We are already familiar about the priority encoders in our before semester. So this priority encoder encodes the input and gives the output. We are giving the input as 8 input, and this priority encoder encodes the 8 input as 3 digital output, where the first one Y0 is a LSB output and Y1 is a digital output and Y2 is also an MSB digital output, where this positive terminal is a non-inverting terminal and this negative terminal is a inverting terminal. This voltage across these resistors at this point, where this 7 by 8 can be calculated by using voltage divider rule, where 7 is a this is a junction, seventh node. So we are writing 7 divided by the total resistance. Total resistance is 8 into applied voltage VR. So 7 by 8 VR. Likewise, at this node, we are writing 6. It is in 6th node. Okay. So then write 6 divided by the total resistance is 8. So 8 into VR. By cancelling this, we get 3 by 4. So 3 by 4 VR. Likewise, we have to calculate the voltage at that points in each nodes. Okay. Let me detailedly know about the construction. It is a 3-bit flash type ADC, consists of a voltage divider network. This is the voltage divider network, and it uses 8 comparators and a priority encoder. Okay, where it is a 8 to 3-bit priority encoder. If they ask to draw a 2-bit priority encoder, we have to reconstruct the diagram for our use. Okay, where each comparator is comparing the input signal. Input signal is analog signal, where it is a VA. Here VA is the input signal to a unique reference voltage. Unique reference voltage is VR. Okay, the comparator outputs connect to the inputs of a priority encoder, 8 to 3-bit priority encoder circuit, which then produces a binary output, binary or digital output. Okay, the voltage divider network. This voltage divider network contains 8 resistors, which is equal value. Okay, a reference voltage VR. This reference voltage VR is applied across that entire network. This reference network VR is applied that entire network with respect to ground. Here, this network is grounded. Okay. Then the voltage drop across each resistor from bottom to top will, with respect to ground, will be the integer multiplies of VR by 8. We are calculating by using VR by 8. It is also said to be voltage division rule. Okay. From 1 to 8 we are calculating. We are calculating this value from 1 to 8 resistor. Okay. The external input voltage, VAC external input voltage is applied. It is also an analog input is applied to the non-inverting terminal. Non-inverting terminal means positive terminal of all comparators. Okay, the voltage drop across each resistor is applied to the inverting terminal of comparator. Okay, the voltage drop are connected with the resistors applied to the inverting terminal. Negative inverting means negative terminal of this comparator. Okay. At the same time, all the comparators compare the external input voltage. External input voltage is VA, is an analog voltage. Analog input is applied to the comparator. The comparator compares this external input with the voltage drops present at the respective other input terminal. Okay, where this is voltage input, this is logical output, this is a digital output y0 and y1 and y2. Okay, where this VA is a non-inverting terminal, this VD is the inverting terminal. It is like this positive and this negative. It is non-inverting terminal VA, then it is an inverting terminal VD, then it is the output X. Okay, this is output X, where this VA is greater than VD means the output is 1, where this VA is less than VD means the output is 0, where this both terminals have equal value means it produces the previous value. Okay, where all the outputs of the comparators are connected as the input of priority encoder. Okay, these all outputs of the comparator are connected with the priority encoder as a input. This is the input to the priority encoder. So this priority encoder produces a binary code or digital output. This is a binary code or digital output. Digital output means it produces binary code output. Okay, which is corresponding to the high priority input that has 1. Okay, so the output of the priority encoder. This output of the priority encoder is nothing but the binary equivalent digital output of external analog input voltage VA. This stanza said that this is the output for the input of analog input, where this is an analog input and this priority encoder produces a digital output. Okay, this is the simply explanation about the flash type analog to digital converter. Okay, then advantages and disadvantages of flash type ADC. Okay, the first advantages is, as I said earlier, it is the fastest type of analog to digital converter because the conversion is performed simultaneously through a set of comparators. Okay, then second advantage is typically conversion time is 100 ns or less than. Okay, then the construction is simple and easier to design, where we can reconstruct or modify the construction of this flash type ADC as we are requiring bit. Okay, then disadvantages, it is not suitable for higher number of bits, so it is not used for higher number of bits. Then convert the analog input voltage into a digital signal of n bit output, we are using 2 power n comparators. Okay, where 2 power n means we can modify the construction of this flash type ADC as our required one. Okay, in this video we are discuss about the 8 bit comparator. So there it means we are used 2 power 3 comparators, where 2 power 3 is equal to 8. We are used 8 bit comparator. Okay, which gives the 3 bit digital output. These are the disadvantages, where the number of comparators required doubles for each added bit. Okay, these are the full explanation about the flash type ADC.